let's get started. Thank you so much for coming to my session. This is going to be a pretty whirlwind trip through WebUSB. So I'm really, really excited that you're here. I do have demos. It's going to be a lot of fun. So just really briefly, I'm Hinton. You can find me online at NoOpCat. That's pretty much on Twitter, Twitch, GitHub, just about any place. You can find me at NoOpCat. In my spare time, I work on open source IoT libraries. A lot of them do tend to be in JavaScript or node.js, or a combination of the two, I guess, because you can webpack a lot of my stuff and run it in the browser. So I'm going to be talking about a couple of those libraries today, but I don't have any time to delve into them. But it's very exciting that all of a sudden I had to use Webpack with a bunch of them because now they work in the browser. During the day, I actually work in developer relations at Microsoft. I'm a cloud developer advocate for IoT. So if anyone saw the IoT keynote this morning, that was very cathartic for me. It was wonderful. So happy that we're actually trying to get the web more ingrained in this stuff. And so even though we're talking about USB today, this is still really, really exciting, and it is generally a push more in that direction that Rob was talking about, which makes me really excited. So I'm really happy to continue that conversation after the break, and I'm really glad that you're here to join me. So today's aim is to help you see the browser and the web in a different way. We predominantly think of it, even with the addition of Electron now, as something that just does webby things all the time, and your main communication interface is with the outside world, or it's directly with the stuff built into your laptop, such as keyboards and things like that. But we don't generally think of it in terms of actual interacting live with devices that are outside your typical peripherals. And I want you to not be scared of hardware and microcontrollers, because I am running a bunch of code and demos that you can also run too if you have the right microcontrollers, and a lot of the ones that are compatible with this right now are actually really, really affordable too. So I'm going to have some links and resources at the end. So the topics we're covering today are a general history of web and devices and how we've sort of scaffolded that in the past to very limited success. We're also going to talk about what WebUSB actually is, just so that you're aware of how it may differ from the previous attempts we've had to connect devices to browsers. How to use it, I'm going to show you some high-level code, and some of it's going to be pretty idiomatic towards low-level WebUSB APIs, which is a good thing, but it may mean that some of it will go over your head today, but that's okay. That's an extra thing for you to go home and research if you're interested. And also features of current support, what we want to see, and also how you can help to contribute to this and start trying out the demos to push this a little further. So let's start a little bit with a history of not the actual official WebUSB proposal right now, but how we've done the two words web and USB and tried to slam them together in some kind of compatible way. And so my journey started with this back in 2007. I was a Flash developer because that's how I got my start in this industry. And so I was doing a lot of ad banners for car companies and all sorts of weird and wonderful full-page takeover Flash websites with progress bars. And so my method to connect something such as an Arduino or another device, that's not a keyboard or a mouse, was to use Flash to do that, and then to put the Flash document in the browser. And the way that we did that was pretty hacky. We used Flash Communication Server. I don't know if anyone's heard of that, but it's a way to be able to listen to sockets and communicate with actual endpoints and things like that. You could technically speak to the cloud and run things like chat rooms and stuff like that. And also we used this wonderful program called srproxy, which took any kind of serial interface on your computer, and it would proxy that through to a TCP port that you could actually then listen to. So it was sort of like this weird translation layer. And so this is kind of how we start every single scenario. It's we have something such as an Arduino, just because a lot of you will already know what that is. We have something like an Arduino, and we have a browser, and there's this deep chasm between them, and we can't get them communicating without sort of gluing some stuff in between. So in this case, we had srproxy, which is essentially a serial to TCP proxy that could basically forward communication from Flash, to the Arduino, and from Arduino to Flash. We would export our Flash file as an SWF file, just in case those haven't used Flash before. That was the format. we would throw that in using an embed tag or something similar like that into a HTML page, and then we had that going. And so you could do really cool things, like you could attach knobs and dials and lights to an Arduino, and then you could push a button in a browser and it would like affect something on the Arduino, or you could just twiddle a knob and it would sort of, change the shape or color of something in a Flash document. And that to me was really exciting. I felt like a wizard because there were bits and pieces that you had to glue together. And so the code kind of looks like this. This is ActionScript at the top. RAP, ActionScript 3 was like really beautiful. This is I don't think this is actually ActionScript 3, but it's close to it. So what you did was you just basically specified like your local host, which is where SerProxy was forwarding things to, generally your port, which you specified in your config file, and you were able to create a new socket from there and start writing and reading from it, which is pretty cool. And then your SerProxy config required you to know pretty low-level stuff, such as stop bits, data bits, the baud rate of the device, and things like that, which communication speed you're choosing, as well as basically like what port you wanted to output to and things like that. And so this was okay, but it definitely didn't feel super production ready. And we kind of know a lot of the history of what happened with Flash. It definitely did not end up surviving. And part of that was just the introduction of the iPhone and not having Flash. And also there were just security issues or accessibility issues. It served a need in our time, and then we got really, really good at being able to fill in the features that Flash provided for us, such as the oodles of APIs that we got with HTML5 as well. So I mean, I'm still sad about this because it was such a great creative platform, and I still use Flash. It's called Animate these days. I still actually use it for creating like JavaScript animations because it does export now to Canvas, which is really awesome. So if you haven't tried Flash in a few years, you should give it a try. It's actually pretty legit. This brings us to 2013. We sort of had a gap with the death of Flash, and there wasn't really a way to do it. But then we ended up with Chrome Serial. And Chrome Serial was around for about 5 years. It's still technically around, so I'll go into detail of what that means, but just like disclaimer, doesn't end well. So again, we have this browser Arduino, we have this chasm in between, and we have this really cool API that's available in the Chrome browser, and it's called Chrome Serial. And you can access it in a very similar way that you access your regular APIs, such as your web audio API, or even just like calling fetch or something like that. The sort of catch to this was that it had to be sandboxed inside a Chrome app. So you only had access to the Serial API if you were basically publishing your code as a Chrome app specifically, but it worked. But you can see here that we still have these kind of translation layers and weird stuff where it only works in certain circumstances. But really, really cool things actually came out of this, and I think that this was sort of where we actually were able to show that we can make much, much better user interfaces for hardware than we could in the past. And there are a lot of advantages to doing this on the web, which I'll cover too. But this example here was the chip computer. Did anyone back this on Kickstarter? Okay, so I'm not the only one. Like, I used to work at Kickstarter, so I backed dozens and dozens of microcontroller boards. It became an addiction for me. And so this came out, this was a $9 Linux computer. So it was like, I'm trying to think. It was, at least a third of the price of the Raspberry Pi. So at the time, it was like really groundbreaking. It came with really cool peripherals where you could like turn it into like a Game Boy and stuff. But what caught my eye when I actually got this in the mail and then I actually started setting it up was they had this really cool Chrome app called the Chip Flasher. And essentially, you would just plug your chip in via USB. You could install this Chrome app, which usually took about 30 seconds, and you could essentially just like update or like reflash the firmware onto this device so that it was all ready to go. And so with the Raspberry Pi, you sort of have to download this image and put it on an SD card, and there's all of this stuff and these steps. But with this, you just plugged it in, and you had this lovely progress bar, and you actually understood what was happening. And it didn't look like malware, which is what a lot of firmware update software looks like. And I should show you one later called AVR Fuses, which has the best logo of all time. I might show you later. And this was great. This was promising. This was exciting to me because I was like, this is exactly what I was trying to do with Flash. And then Arduino, the company, actually went on to create a browser-based IDE. And you could not only write code and learn how to use the Arduino and import like libraries that were already available, within the IDE, but you could also compile the code, with the help of the cloud, but still, you could compile the code. We can do that in WebAssembly now. And also, it would upload the code to your device, all in the browser. All you had to do was plug your Arduino in and go to create.arduino.cc, and that's how you got started, which is really, really, really exciting. In humble brag, they're actually using my firmware upload code in this, because we can do it in the browser now, which is really exciting. It's sort of been sunset to a degree, and there are a few reasons for this. And so it wasn't an official web spec. It only worked in Chrome apps, which was very difficult because you could have this cool website, but you'd have to have like a companion app that then was able to have the permissions to do the serial stuff. And so you weren't really truly going to like a web address, and it just worked. And also Chrome apps were sunset in 2017. They only are supported now in Chrome OS. And so the Arduino Create platform still works really super well in Chrome OS. And I'll talk about the workaround they had to do for every other operating system, because it does still exist and it's still compatible with Mac OS, Linux, and Windows. Which brings us to today. I guess today, this is sort of what we're still doing, even though WebUSB has become a new proposal. So don't confuse this with like what WebUSB is, because they are very different. What we do is we still use a browser, but we use WebSockets. So again, these two items, there's like miles between them because they can't talk to each other still natively. And so we generally have a node.js process, which is running something like node serial port, which is one of my favorite packages in the world because I use it in almost everything. But then the Node.js can use node serial port to talk back and forth with the device because it's using low-level native modules in order to do that. And then we have a WebSocket that is basically a game of telephone between the browser and Node.js process. So Node.js will say, hey browser, the Arduino said this, and then the browser's like, okay, well, can you tell the Arduino this? And then it becomes this, schoolyard gossip session. But it does work. It works very well, and it's probably a lot more reliable than a schoolyard gossip session. And so this was an Electron app that I made for another Kickstarter project that a friend of mine ran. This is the public radio, which is a monogamous radio where you can only listen to one radio station, which I think is a really cute idea. And they were so wrapped up in the manufacturing and the shipping and the production and all of those kind of things that they kind of ran out of runway to create a program that would help people change their mind. So it was radio monogamy, but if you decided to pursue a different radio love interest, you could do that. You could just listen to one at a time. So this program was designed to allow you to change the radio frequency. And this was mostly distributed to people who had the kits that they were soldering together, but technically you could still use it with the radio if it was shipped to you fully assembled. And so it did things like frequency band, de-emphasis, channel spacing, just so that it supported all of the different international standards, of which I learned a lot about when making this project. And so this would basically package up a piece of binary information and write it to the EEPROM sort of location of the chip, so that when you turned it on, it could read that back and figure out which radio station to tune to. So this was really nice because, again, it doesn't look like malware. It's a modern interface. I'm not a very good designer, but I was still able to put something together, and I could see the promise in this. It just required me to have an actual Chromium, an entire Chromium app running. It was 100 meg just to be able to change this radio station, which was a big compromise. And the Arduino editor, the Create IDE, which is running, which does run on Mac OS, Windows, Linux, and Chrome OS. If it's not running on Chrome OS, it does have a companion app that you install to your computer, and it's basically using WebSockets to communicate in order to flash to, and by flash I mean it just uploads your compiled program to your board. And so it does technically still work, but I was snooping on the port to see what the communication was, to figure out if that's what they were doing. So if these are all the things that are not WebUSB, but was our attempts to sort of get to this point, which actually does focus on serial, WebUSB is a little bit different. What is actually WebUSB? And so I'm going to be pulling from the WebUSB spec a lot because it has a lot of what they call non-normative text in it, I believe, where it's actually pretty readable. And so I would encourage you, if you're interested, to go and read up on it because it covers specific things such as security concerns and all that kind of thing. And so I found it really, really interesting and very, very helpful because I needed this spec in order to start interacting with devices such as the demos I'm going to show you today. And when you only have the bleeding edge spec, you need all the help you can get for that spec to actually be accessible and readable and easy to follow. So the WebUSB API provides a way to safely expose USB device services to the web. That's a pretty generic statement, but the important thing here that I really want to talk about is that it provides an API familiar to developers who have already used existing native USB libraries. So it's not like Chrome Serial where they're reinventing this new sort of API where it just doesn't really follow what you would normally do with USB devices. And it exposes the device interfaces defined by existing specifications. So again, rather than inventing a whole new protocol, which we heard in the keynote today by Rob, if you've already used something that's lower level, such as the libUSB library, this is going to be extremely familiar to you. It's going to make sense, and you're not going to really have to modify a lot of your code to get this going, which is really exciting. And that's what I found too. I was using a node.js package that's basically an abstraction and writes native node modules for libUSB. I literally didn't have to change anything about the actual code I wrote. I literally webpacked it up, and that to me is actually super, super powerful. But it's important to know that WebUSB and the way that you communicate with the device, it's not the same as serial. So a serial interface is something that you can screen to and do things like that. That's not the same interface that WebUSB is. It's more of this standard lower level way that you interact with devices. So I just want to make sure that's not confused, because a lot of the previous stuff that I showed you was actually using something such as a serial interface, TTL. So why is WebUSB better then? I sort of covered this a little bit before, because it's just using existing standards and it's not reinventing the wheel. But another thing I really like is that finally users can actually specifically give permission to connect to a device, which feels a lot more secure. That was not the case with Chrome Serial, where if you plugged in an Arduino, I could just erase it without you knowing about it, which was fun, but it's not great. So I'll show you sort of the code to get this going, because you can provide filters. If a user has a billion USB devices plugged in that speak, libUSB, for example, you're going to get a whole list of them, but you can actually filter based on your specific device, which is really cool. And so there is a user-initiated gesture in order to even get this to pop up, and then they have to then confirm that that permission, and I'll show you sort of the flow of how that happens in a second too. And my favorite feature is that any device out there, whether it's 20 years old or whether it's 6 months old, that as long as it uses the USB communication protocol, you can start interacting with it immediately. But if you were to update the firmware or the bootloader on that device in order to have an additional proposed device descriptor, specifically for WebUSB, you can essentially store a URL in that device descriptor. And so as soon as you plug in a device, you can advertise that, oh, I actually have a specific website that I work really well with, and that could come from the manufacturer, or it could just be a community-run project. And so it actually guides the user through saying, oh, you've plugged in this device, it's telling me that you should probably go to this URL because this is where all the magic's going to happen. They can click on that notification that pops up in Chrome, and they're taken to that website immediately. So I'm going to show you a demo of that too, but I think that's super, super exciting. And again, it's not required to start talking to devices that are 20 years old. They still work, and I'm going to show you one of those. But if you do want to put this device descriptor on your devices going forward, it's actually really, really great for the user. But you're probably thinking, we're at a JavaScript conference, and as JavaScripters, we're known for we have this JavaScript hammer, and everything looks like a nail that can be solved with JavaScript. So why? Why would we start doing this in the browser when we've already had perfectly good solutions in the past to interact with hardware and we've gotten on by? So this is really just heavily peppered with my opinion, but I really do think that hardware interfaces should be fast to make. They should be cross-platform without any effort. They should look good, and they should also be accessible and have this again, consistent accessibility cross-platform as well. And it just so happens that conveniently, browsers are also a commonly installed application on many computers. So I think that that's actually a really good starting point. And then even more conveniently, browser-based interfaces, I would argue, are rapidly prototyped. You can hot patch them super easily. You can deploy an update to the cloud in like 2 seconds these days. CSS is super powerful for styling. And with the GPU hardware acceleration we have these days, you can create really performant interfaces that might not be like native, but they're a very good experience for the user. And we have a consistent accessibility tree to reason about, which is really, really nice. I've used a lot of hardware programs that I can't even like tab to the dang buttons or fields because they're using some weird cross-platform UI that works with a specific version of Python, for example, or something like that. And I've definitely run into that. It's been very frustrating for me to make accessible interfaces where I'm testing it in every single operating system. And I just really do not have to do a lot of that manual accessibility testing. If I'm using the browser and I know that that's going to be a thing that shouldn't change too much from operating system to operating system. And the WebUSB spec kind of calls out a few exciting things about just the opportunities with this, which is with this API hardware, manufacturers will have the ability to build cross-platform JavaScript SDKs for their devices. And so being able to bring these SDKs to market way quicker, instead of waiting for this really cool device to finally start having JavaScript access to it, it's just, you're going to be able to play with it immediately because as long as you can download the datasheet for the actual device, you can start looking at how to actually start communicating with it. So it's not as straightforward as a JavaScript SDK, but you can like basically roll your own and you can wait for the community to roll one for you if you're not as skilled in that area. So WebUSB use. Let's go over that really quick before we do demos. So again, I talked about how there needs to be a user-initiated event, so something like a click or they hit a button on a keyboard to activate some piece of UI. The browser then goes and looks for devices, and that can go and look for devices based on like a filter that you provide. It returns any matches it finds, that it knows you're going to be able to start sending and receiving to and from. The browser then asks for that permission. It says, hey, I found this device. Are you sure you want to connect this website to it? The user will hopefully say yes. And then it'll open the device connection. You select your configuration. You claim your interface. This is all the kind of like USB spec stuff. And then you start beginning transfers back and forth. So you can read from it. You can write for it. You're all good to go. And so this is the bare minimum code to sort of start getting that pop-up to come up for the user permission. And so I can wrap this in like a click event, for example. And so I'm filtering on vendor ID here. I think this is the Adafruit Feather 32U4, which I have on the stage. That's Adafruit's vendor ID, but you can also do product ID specifically. So I can say anything made by Adafruit, or I can say just this specific thing made by Adafruit, which is pretty powerful. I can use async await with it, which is awesome for hardware. I cannot tell you how excited I am about using async await with hardware, because we have a lot of serial commands that need to happen synchronously. You can access it on your Navigator object in your browser globally. You request the device, you pass in your options, such as your filters. And then from there, you can actually just, if you get like one match, for example, you can just start doing device.product name and manufacturer name, and you can look at all the different descriptors that you get back from the device, which is very, very easy because it's only a couple of lines of code. So if you do learn about USB, this becomes pretty straightforward. So again, I have some repeated code at the top, but I can essentially open the device, I select which configuration I want, I claim the interface that I need, which is basically saying these are the endpoints that are the read endpoints and the write endpoints that I want to do, because some devices can have multiple. And then you can just start doing things like transfer out and transfer in, which are extremely normal specified USB methods to call in other libraries outside of JavaScript, which is really, really great. And yeah, you can just await a response. So I can ask for 5 bytes from endpoint 2, which is really cool. And then I can just console log out the response. And so again, if you're sort of worried about like, where do I find these product IDs? Where do I find these vendor IDs? This is a data sheet for the AVR ISP Mark II, which I have on the stage. And so I literally use this in order to filter it and also to find out like how many configurations it has, of which it has 1. So I'm just going to request 0, the 0th configuration, and things like that. So if you find a table like this, this is where it's really useful. And this is where there'll be an additional descriptor, which is the WebUSB specific one for the URL to be stored on the device. So the URL, so the device doesn't actually serve a web page or anything like that. I want to make it clear. It just has this string as a URL to suggest that the person goes to that website, and that website is just hosted in traditional forms, whether it's local or from the cloud. So let's do some demos before I run out of time, because I only have 7 minutes. The reason why I do fingers crossed is that it's a changing landscape, and some of my stuff is duct tape city because I don't really have any other friends who are doing this, and so I don't really know whether I'm doing stuff in the right way. And webpacking up hardware software is just weird still, and there's a lot of shimming and stuff. So I just wanted to give you that disclaimer, but I think it's going to be really fun. So what I have on the stage right now is. This looks really scary, but it's really just like a very convenient way for me to have 2 boards talking to each other. I essentially have an Adafruit Feather 32U4 board down here. This is a very standard and very accessible and affordable microcontroller that they sell. It basically behaves like an Arduino. And then up here, I have like a breakout board that kind of normally would slot on top of it, and it's a screen. So I can just like display stuff on the screen. And so, when you have, there's no console log on hardware, so you have to kind of show stuff through things like screens. And so what I'm going to do is I'm going to plug this into my USB port, but I'm going to bring up my browser because I want you to kind of see what happens when I actually plug this in. I thought that I had the turtle. I must have changed from the turtle to the cat. That's fine. All right, so I'm going to plug that in, and you might actually see that come up already. So it says 32U4 feather detected, go to webusb.fragile.systems to connect. That's my domain name for like really fragile demos, just to give you that disclaimer. So I'm actually going to click that, and I have new internet. That's awesome. I didn't think of that. So it's node.js interactive. What's the password? It should be on your lanyard. Is that it? Yeah? That was such an anticlimax. That was like the last thing I was thinking of on stage. All right, we got internet. Let's do this. The other demo I have is running locally, thank goodness, so we got to back up. All right, I'm going to click it again. Magic. It actually loaded. Cool. So this is basically like a virtual representation of all the pixels on this screen. So unfortunately, the conference renamed themselves, and so I don't know if I can fit that on here. So I'm just going to write like node plus JS instead of like node plus JS interactive because, yeah, when I planned this demo, I actually had less words to write. All right, so I'm going to write node plus JS. I'm not going to win any awards for this artwork. But essentially what I want to do now is I have like I should just make this a little bigger for you. I have a button that just says connect. So this is my user-initiated event, right? And so it's found my Feather 32U4. It's previously paired because, I've given it permission before. So you can actually skip this part. It's just I have it pop up every time because I want to be able to show you that. Once I've connected, I can either disconnect or I can send this image. And so what I'm going to do is I'm going to do a really awkward thing where I try and show myself pressing the button and the actual image at the same time. I think this actually might work. So I'm going to hold this up and pray that it's not upside down. And then let's see if we can get this image to show up. And there we go. And so that was the first demo. That's actually very straightforward to understand. The second demo is not so much, and hopefully I have time to do this. How much time have I got? Yeah, I got 3 minutes. All right. And so this is an Arduino. It says bricked just because it doesn't have the Arduino bootloader on it, so it just reminds me that I can't use it for normal Arduino things. So I have an Arduino here, and we want to be able to upload programs and things, right? We want to be able to have eventually the Arduino Create platform. It would be nice if we could do this directly. So I have this, but I'm cheating. So I have this AVR ISP Mark II device plugged in, and this basically is able to kind of circumvent the traditional kind of way that you upload programs to the Arduino, which is usually via serial, right? And so this allows me to, this is a WebUSB device here. It probably came out almost 20 years ago now. So this is just showing you the power of WebUSB. You can interact with devices that came out like decades before WebUSB. And so I'm gonna plug this in. I don't actually have like a cool device descriptor because this is a 20-year-old device that doesn't know what WebUSB is. And so instead what I'm gonna do is I'm just gonna run this local experiment that I have and pray. And so I thought that web interfaces should look as cool as like 90s web. So this is my 90s web ode. And so what I'm going to do is I'm going to connect to the programmer and tell the programmer to upload a file that I'm hosting locally on my machine, just in that same directory. And it's going to say, hey, can you just like write that program to the memory of this chip? So that's literally what it's doing. It's uploading the code to the Arduino. And then it's also going to fetch a bunch of different things like the product name and the device signature, and also the signature, the specific byte signature of the chip, just to verify that, yes, this is the chip that we're expecting to talk to. So I'm going to connect. I have my AVR ISP Mark II, again, a 20-year-old device. It got the AVR ISP Mark II programmer signature, which is a device descriptor. Actually, no, it's not. I'm reading it straight off the device and changing it to ASCII. But what you're seeing here is that every single hash you saw was basically like happening when a single page of memory on this chip was actually written. And so the only change I really made to my JavaScript library that's able to talk to this programmer, which I initially wrote for node.js, was I emitted an event every time a page was done, because all of a sudden that was actually like really important to me, because then I know the progress of it. And if you've ever used AVRDo before, you'll see that this is a very similar interface that I'm trying to emulate to kind of show the power of that. So it's really exciting that it's literally live uploading the program to the chip, and it's really just, it's uploading a script that makes the LED blink. That's really all it's doing. So that's kind of like, you can write stuff to the screen with Arduino, but you can also like start messing around with devices that are 20 years old too, which I think is really exciting. And that's sort of what this programmer usually looks like. You usually just program bare chips with it. I'm cheating with an Arduino because it supplies power to the chip and it's just easier for me to demo, but you could actually do stuff like this as well, which is really, really exciting. And so in the 30 seconds that I have left, I'm just going to quickly give you a preview of what I used to do this. And if you don't get these details, just come and find me. I'm actually going to be at the Microsoft booth straight after this, so come and find me during the lunch break. Demo number 1 was made with WebUSB Serial, which is basically just a shim to make Serial behave like WebUSB, because we are still speaking to an Arduino via Serial. Johnny 5, because makes robots easy. OLED.js, which is the library that's able to kind of make the frame buffers for the screen, and so that works with Johnny 5. PNG to LCD, just to convert, again, pictures to frame buffers, because you can upload pictures. OLED.js Designer, which is made by my friend Rachel. She's excellent, so she made that awesome screen interface that I was using. And Webpack, which was the most unexpected tool in the world for me to use for this, but it allowed me to swap out things like the buffer API and things like that for byte arrays. So that was actually really, really convenient for me. The second demo is made with a bunch of my AVR Girl series of software, which just communicate with Atmel chips, basically. And so I have one for the protocol that the programmer speaks, and I have one for the protocol itself, which is, the programmer itself, which is a wrapper, and Webpack, lots and lots of Webpack. Lots of bad code written on a plane, which is why it's hosted locally, but I was really excited to show you that demo. I'm hoping you understand the demo enough to see the potential of it. So futures. We actually have WebUSB support already in one of our Microsoft products called Microsoft Make Code, where you can drag and drop programs to upload to a device. So it's really exciting that there are already devices where if you just modify the bootloader slightly, you can actually start writing directly to devices in exactly the scenario that I was trying to show you, which is super, super exciting. Definitely check out Microsoft Make Code. It's a really cool collaboration we did with a number of different microcontroller vendors like Adafruit and BBC. So you can see here, it's like right in the Adafruit documentation. I'm so excited about it. So I'm hoping to see more of this. Current support, But if you plug something into your phone, you can start playing with your phone and devices, which is pretty exciting. So why support this? Well, I'm going to end on a couple of quotes because I am over time. I apologize. This is from Riley from the spec. This will be good for the web because instead of waiting for a new kind of device to be popular enough for browsers to provide a specific API, new and innovative hardware can be built for the web from day one. That's really exciting. We actually get to say over this stuff now. We actually get to say, no, hardware interfaces are crap. We can do better than this, and that's definitely a mission that I'm pushing right now. So if you want to actually use an Arduino, they do tell you which ones are compatible. You can go to that middle link there, which is just github.com/webusb/Arduino. They have instructions. You can get started with it. You can just use the little built-in LED on your Arduino. So you don't even need to connect anything to it. You can start blinking an LED or something. They have a couple of examples for you to do. And if you want to see my crappy duct taped together like first demo, which is just kind of making, it's mostly a fork of my friend's OLED.js designer, and I just kind of like slammed some WebUSB into it. Definitely check that out because the source code is very interesting. And yeah, come and see me if you've got questions at the booth, but because I'm over time, but I wanted to thank you again for coming to this talk.